which is obviously super wrong, and looks like a 16-bit address made 32 bits. So it's quite interesting. Okay, I told you about IOCTLs earlier. It's not that they're not working at all. If you try fuzzing IOCTLs, if you try fuzzing device drivers with IOCTL, you will most probably find bugs. I found one in VMware. Trouble is, so it's using the /dev vmmon device driver, which typically requires root privileges to trigger an IOCTL, because you need root privileges to open it. So I reported it to VMware more than a year ago, and these guys were like, okay, this is not a priority bug to us, because typically this is not a security vulnerability. Okay. It happened it's a null pointer dereference. So how do you usually exploit null pointer dereference in kernel? Yeah, you use mapping in userland. But truth is, nowadays, this is not supposed to be possible, right? So after 2.6.23 kernels, the guys from Red Hat thought, okay, we have way too much null pointer references. So what we're going to do is a generic fix for it all. We're going to prevent mapping of the first page at all, unless you root. Root can do anything. Turns out that on default Ubuntu vServers, so the virtualization environment, which can be built in the kernel to run different instances of the userland environment with only one kernel. Turns out, by default, on my Ubuntu, let me give you the exact number of my kernel. So 2.6.31.20, this protection is not there by default. This can be tuned with the /proc pseudo file system, and turns out an unprivileged user can map to the first page. Still, let's assume this mapping thingy is doable, either because you root or because it isn't set. What happened? Okay, so how do you exploit this null pointer reference, assuming you can map anything you want in userland? Sorry? Okay, what happens is that 0 for the kernel is 0 in userland. This is not the case in every architecture, but it's the case in Intel CPUs. You can map whatever you want, wherever you want in userland, which means if the kernel tries to dereference a pointer inside the first page, you can map whatever you want there, either code or data. The typical way to exploit those kind of bugs is to try to find a function pointer which is dereferenced via null pointer dereference. It means code is going to be executed inside the first page. So you just map your code there, and your code gets executed. This is usually how you get a root shell out of such bugs. Turns out, in my case, there was no such function pointer inside the reachable code via my vulnerable IOCTL. So then, what do you try to do? Ivan? If there's no function pointer, what do you try to do? MyBT? Okay, absolutely. First thing you'd like to do after function pointer is typically trying to find an arbitrary write that you, if you control a given register, you'd like to find a place where it's used as an index to write in memory, which means you have an arbitrary write at least you can write to any place in memory. And if you also control the second operand, you just have an arbitrary right with arbitrary content in memory. Turns out, in my reachable code, no luck. I had zero such write primitive either. So then what do? Then you go for using special features of this particular device. So after a long time, I realized that with my particular bug, which seemed non-exploitable, I could leave the kernel in such a state that a spin lock was left. So what happened is that the kernel tries to read from a memory which is not mapped, and it does so before releasing a spin lock. So then, modern Linux kernels will try to handle the oops the best way they can, and not to die because of it. And the particular handling routine, which is trying to handle this null pointer dereference, is trying to access timers. And when you have a spin lock which is still set, this is very bad. So, in a sense, what I could do with my lame bug is, assuming you can map 0, so either you root inside a CH root or inside the server, or the device is mapped so that you can access it without being root. What we can do is basically get a kernel DOS. Or maybe a bit better, because inside my kernel logs, and I even managed to get crashes that generated files inside the on my file system. Typically generating files